topic is diode digital logic gate. And when you say logic gate is a digital circuit that performs logical operations on one or more input signal to produce output signal. So we want to have a circuit that we're going to give two signal, and we want to have one output signal. And if you're talking about logic gate is digital circuit, and all the logic gates, they have their signal will be in two states, either 1 or 0. If a signal is 1, that means we can say it's on or it's high, or we can say it's true. In some truth table, we say true. But when a signal is 0, it means off. You can say off or low. You can say off or low, or you can say false. But what we want to use in this practical is on or off. If you have our signal to be 1, it means on. If our signal is 0, it means off. So that's what we want to do. We want to have logic gate that we're going to have two signals. So then we've discussed about digital circuit, and we discussed about logic gate. Logic gate, we have about 7 logic gates, but our practical we base on only 2 logic gates, AND gate and OR gate. So we want to verify the features of AND gate and OR gate. So for our AND gate, so we have been given a circuit here. We have a circuit, diode digital logic gate. We have been given a circuit whereby we are going to use 2 diodes. Then we need a resistor connected to the source. Then we need voltmeter to measure the output. Then we need 2 switch, which will serve our signal. This is the first signal, second signal. So switch 1, switch 2. So when we close this switch, what will happen at the output? When we close this switch, what will happen at the output? When we open the switches, what will happen at the output? So, and this is the table that we want to use to fill the table. When switch 1 is 0, that means when it's off. And switch 2 is also 0, it's off. What are we going to have at the output as the voltage? That means we are going to, this is voltmeter. We put voltmeter at the output. We are going to put 5 volts to the circuit, and we are going to on and off each of the switches and see what we are going to have at the output. So to see the features of AND gate, let's start from the objective. Identify and demonstrate operation of diode digital logic AND gate and develop truth table of logic function. Examine the circuit shown in Fig 27-3, which is this. We have to examine it. Then so with the addition of switches S1 and S2, we have 2 switches and the voltmeter. So switch 1 and switch 2 are used to change the gate condition of input A. Our input signal A, our input signal B, we use switch to change their state, either at 0 or at 1. At 0, that means off. At 1, that means on. Note that 0 position, switch 1 and switch 2 represent 0 volts, while 1 position represents 5 volts, because we are going to have 5 volts in this circuit. So the electronic voltmeter, that's our voltmeter, is used to monitor the output voltage at the output voltage for these various gating conditions. So now let's now see. Then I say what identify this circuit as a diode digital logic gate, because we have 2 diodes, and those 2 diodes are the anode side is connected to the power, connected to the positive. So therefore the cathode side will be grounded. So this shows that we are going to have an output if both switch is on. That's when we are going to have this shows that this circuit is AND gate, because the 2 this is anode side of the, we have discussed about diode before. This is anode, this is the cathode, and those 2 cathode. So these 2 cathode is this. Then the 2 cathode will be grounded by the output. towards the output. Why, when you switch it on, the anode side will be what? Will go to the positive side. So this shows that this circuit is AND gate because it's forward bias. This is the anode side. When you close it, it will go to the positive. This one also, when you close it, the anode side will go to the positive. While the cathode side is being grounded through the voltmeter. So that means, is the two diode is forward bias. It shows that if any of them is reverse bias, is open. So there will not be anything at the output. But before we can have anything, before we can have signal at the output, so both the diode 1 and diode 2 must be what? Forward bias. So this shows that this circuit, what identifies the circuit as a diode digital logic AND gate, because we have two diode forward bias. So and then we have two switches to control the signal, the state, the signal of each of the diode. So that's that. Connect the circuit as shown in fig 27-3. We are now asked to connect this circuit diagram. We are asked to connect it. Adjust the power source to 5 volts. We have to inject 5 volts to this. Set switch 1 and switch 2 to 0 position. Record in table 27-1. This is 27-1. So then the output voltage indicated on the voltmeter, we have to record it down. So let's now do it now. Let's have the circuit. This is the circuit here. So we have switch 1 and switch 2. Then we have two diode 1, the diode 2. Then the resistor, 4.7k resistor is there. Then we now inject our circuit with 5 volts. We have 5 volts here. So if I use this one, that means I have to vary it until I have 5 volts. But this is 5 volt direct. So this is my circuit and I have 5 volts direct on that switch. And as you can see that the two switch are in position 0. This one is 0, this one also 0. So when you look at our meter, when both, we let off our light and see. Now let's now inject power to it. When we inject power to it, what do we have? When we have two switch at 0, we have 0.5. So now let's look at this second stage. Switch 1 is 0. Switch 1 is 0. Switch 2 is 1. So our switch 1, this is switch 1, switch 2. Switch 1, 0. Switch 2, 1. Let's on it. When we on the second switch to be 1, what do we have? 0.54. When switch 1 is 1 and switch 2 is 0, let's put this switch, this is switch 1, put it to 1. And let this one be 0. So look at it. This is 0 here. Switch 1 is 1. Switch 2 is 0. So what do we have? 0.52 volt. So by the time we now put both switch at 1, and this one 1, you can see what we have, 4.96 or 97 volt. This is what you have. This table 27-1 here, this is it. So when we have switch 1 off, switch 2 off, we have 0.5 volt. So when we have a switch 1 off, switch 1 on, 0.54. When we have switch 1 on, switch 2 off, we have 0.52. When we have both switch on, we have this. This shows that this is an AND gate circuit, because in AND gate we are going to have our output only when both switch is on. That's when we're going to have our output. If any of the switch is off, we're not going to have anything at the output. That's the AND gate. So now we have our table. Set switch 1 and switch 2 to each combination of the position listed in this table. We've done that. Record the output voltage for each combination. We've done that. Look at the result of the table 27-1. The result, okay. When the combination of the switch setting resulted in an output voltage approximately equal to 5 volt supply DC. They say out of this setting, which one give us approximately the value of our input? And if you can see, it's that point is at point whereby we have switch 1 to be 1 and switch 2 to be 1. When both switch are on 1 and on position, that's when we have our output voltage to be approximately equal to 5.5 volt DC. So that's what they ask us at F. So at what combination? That combination is at when switch 1 is 1 and switch 2 is 1. That's when we have that value. Is the output voltage close to 0 volt for all other switch combinations? Yes. You can see that to other combinations 0, 0, 0, 1, 1, 0 is approximately equal to close to 0. The output close to 0. So note, there will be a small voltage drop across the diode in forward bias. Yes, we have some voltage drop because the diode is forward bias, so we are having a little voltage drop. So assume 0 volt represents logic O. If 0 is O and 1.15 volt represents 1 in your circuit, write the logic equation for the diode digital logic AND gate from the result of table 271. Remember, AND gate provide output only when all the input gating conditions satisfy. Use A and B as the input and C as the output. If you are to use A and B as the input, let's say we have our switch 1 to be A, our switch 2 to be B, and the output to be C. So when switch 1 is 0 and switch 2 is 0, that means we have 0 at the output. When this one is 0 and this one is 1, we are going to have 0 as well. So when we have 1 at the switch 1 and 0 here, the same thing, 0. But we are going to have an output only when both input is 1. It means that if you want to write logic equation for this now, it means our output equal to A and B. Or we can say our output equal to A dot B. So we are going to have, this equation shows that we are going to have output only if we have both input to be on or high. If any of the input is low or 0, we are going to have our output to be 0. That is what we are asked to do. Reduce power to 0, we are now asked to reduce the power to 0. So we are asked to reduce power to 0. We are now asked to reduce power to 0. But because we use 5 volts straight, let's off our power supply. So we have off our power supply from the circuit, and so what we have there now is 0. So we have done that. Now the next thing for us is to verify the AND gate again. Instead of using voltmeter to determine the output, we will now put LED or miniature lamp to verify operation of AND gate. Let's go. Now we want to verify AND gate again by using this circuit. We want to have this circuit. So instead of voltmeter at the output, so we now have LED. Then we are going to use transistor, so to control the flow of voltage towards the LED. We're going to use our diode, 2 diodes. Then we use resistors and 2 switches, so to control our. Let's see what we're asked to do. They said now you will verify your logic equation using light emitting diode. We need light emitting diode now, though I use miniature lamp instead of LED because I don't want those, because the LED can get burned. Though I can use resistor so that it will not get burned, but I have miniature lamp to use instead of LED, the same thing. So I use our LED, put it at the output of the digital logic gate. So connect the circuit shown in Fig 24 to 7. All components associated with LED CR3 are permanently mounted on. Okay. But we are not using this. We are using a breadboard. These components include driver, transistor. Yes, we use transistor. So and then we use resistors. Resistor 1, resistor 2. This is the circuit. We need 4.7 K resistor. We need 1.5 resistor, 150 ohm resistor. Then we need miniature lamp or LED, anything that can come up that can give us light here. We need transistor here. The base of the transistor to the we connect it with the anode of the diodes, then the emitter to the ground, the collector to the LED. Then we need two switch. So connect it. That's what we've done here. We need two switch. These are the diode. You can see the anode of the diode. So we use this resistor, which is 1.5 resistor, connect to the base of the transistor, and you can see the emitter of the transistor connected to the ground. So while collector connected to the miniature lamp. So that's the circuit. That's circuit. This circuit diagram is what we've done there. So we are now adjust power source to 5 volts. Repeat the switching setting of 27 to 1. That means what we've done before. When we have voltmeter, we have to do it again and see what will happen. Yeah, let's go. Let's start from the switch 1. Switch 1. Let's put it to 1 and see. Maybe we are going to have. Let's see. This is our LED. So do we have anything? We don't have anything there. So let's move it back to that's okay. That means 0 and 0. When both of them are 0, switch 1 0, switch 2 0. We don't have anything from our LED. That means we have 0. So when switch 1 is 0, switch 2 is 1. Switch 1 0, switch 2 1. Let's put it to 1. So you can see the same thing. We don't have anything. That means it's 0 again. So when switch 1 is 1. So let's see if you have switch 1 to be at 1 position, switch 2 at 0. So we still have 0. So let's now put the 2 switch at 1 position. So let's see what will happen. So by the time we put the 2 switch, now we now have 1 because the LED is on. The LED is on. So can you see now? So the LED is on when we put the 2 switch on 1 position. So that means that's what we are asked to do there. So that's what we are asked to do. So he said the LED will light only when driver transistor Q1 is forward biased by the positive voltage output of the AND gate. And this should occur only when the input gate conditions are satisfied. Which combination of switch setting cause the LED to light? They now ask us here which combination. You can now see that when the switch 1 is at 1 position and switch 2 is at 1 position, that's when we have the LED light, when we have the 2 switch. Does this verify the AND gate logic equation C equal to A and B? Yes, it has verified that. It's only when we have input at A and at B because we have an output. If we don't have input from either of these, we are not going to have an output. Yes, it's verified. If the O and 1 position of the switches represent logic 0 and 1 respectively, then the output of the AND gate can be stated as logic 0 or logic 1. Also for the various input conditions, this gives rise to what is known as truth table. So our truth table, we have done it, which is used to predict the operation of a given logic circuit by taking all combinations of input into consideration. Then determine the expected output. Assume 0 and 1 position of S1 and S2 do in fact represent logic O and logic 1. Then it can also be assumed that logic O is indicated when the LED is off and 1 is when it's on. Using the truth table 27 to develop a truth table for your diode digital logic AND gate for the various input conditions listed. If necessary, use the test circuit so as to assist you or to confirm your result. I think we have done it. Here's the table which we have done, and our equation will be C equal to A dot B. So that means we are going to have output only if any one of them is 0. Remember our probability in secondary school. So if you have AND in probability, that means it's multiplication. That means it's A times B. If any one of them is 0, the output will be 0. You are going to have 1 if both of them. You are going to have output if both input is 1. So our probability in secondary school, so is when you have two of them, so the output will, if any of the input is 0, going to have output to be 0. That's what we have here. C equal to A and B, or A dot B. That's the equation. Reduce the power supply to 0. Then we are done with the AND gate now. That's what we are asked to do in this practical, to verify AND gate by using a voltmeter to, to see what will be the output. Also to use LED or lamp to see what will happen at the output. Let's go to OR gate. Identify and demonstrate operation of diode digital logic OR gate and develop two table for the logic function. What we've done in AND gate, we are just going to repeat what we've done in AND gate. So look at our OR gate circuit. This is OR gate. So you can see that the anode side is grounded, and the cathode will be, and the cathode side is grounded. Anode will be, this is cathode, this is anode. Cathode is grounded, and you can see that this anode is, when you plug it, it will come to this side. So this shows that when we ground the cathode, the two of them is grounded. So it means that we have the neutral from the power source already to the circuit. Once any of this is on, so we are going to have output. Output have negative already from the output, because this place has been grounded. If any of this is what is, if any of this, if you have positive from here to this place, to just flow and give us output. So this shows that this is OR gate, or this is OR gate. This is the diode digital logic OR gate. So because if any of this switch is on, so we are going to have our output. If both is on, we are going to have our output. So this circuit is what we've just did now. So look at the circuit here. Switch 1, switch 2, both the diode. So the first one we did, the cathode, the anode is combined together. But here, here you can see that the cathode is combined together. But the first one, anode is combined together. The anode, the positive side of the diode, which is anode, is combined here for the AND gate. But now we have interchanged it. Now we have cathode to combine together. So, and then we have our resistor grounded for the OR gate. But for the AND gate, we have this resistor at the positive of the power supply. So that's the difference between the AND gate and OR gate. Look at this OR gate now. So this resistor is grounded, and both our cathode side is being combined together. So then the anode, each of the anode connected to the power supply. That's what we did here. Look at it. Each of these connected to power supply. Each of these connected to power supply. Now let's now see what will happen to that table. Then we are given table there, table 27 to 3 to fill. So set S1 and S2 to each combination of switch position listed in this table. Record output voltage for each combination. So let's now see if we have, so for 0 and 0, let's have our 5 volts. We have our 5 volts from the power supply. This is 5 volts. So put it to our circuit. So 0 and 0, you can see that we have 0. If switch 1 is 0, so we have 0, no voltage. So let's switch. When we have switch 1 0, switch 1 0, switch 2 1, switch 1 0, let's on switch 2. Let's see what we have. What do we have? 4.42. 4.42. So when you have switch 1 to be 0, switch 2 to be 1. Now let's have switch 1 to be 1, switch 2 to be 0. Okay, 0, and let's have this one 1. So what do we have again? We have 4.37 volts. So let's see when we have the both switch to be 1. So we have 4.44 volt. So that's what we asked to do here in fig table 27 to 3. So this is what we have from our experiment. Look at the result of the table's combination switch of switch setting resulted in an output voltage approximately equal to 5 volt. The one that gives us almost 5 volt is when you have 0, 1, 1, 0, and 1, 1. When switch 1 is 0, switch 2 is 1. When switch 1 is 0 and switch 2 is 0. When switch 1 is 1 and switch 2 is 1. So all those combinations give us the value closer to the input voltage, which is 5 volt. That's the only combination that gives us 0 is when you have switch 1 to be 0 and switch 2 to be 0. That's what they ask us here. You use this table to answer that question. Is the output voltage 0 for the remaining switch combination? Yes. For the remaining one, this only one, you have 0. We have done that one. From the result of your measurement, write the logic equation for the diode digital logic OR gate. So assume 0 result is logic O, 5 is logic 1. Remember, all gate provide output when one or all input gating conditions are satisfied. Use A and B as the input and C as the output. If you're asked to use A as the input, so let's say we can have table for that one as well. We can have the table like this. So we can have that table 0, 0, 1, 1. 0, 1, 0, 1. So when this one will be 0, this one will be 1, 1, 1. This is the truth table for all gates. We are going to have 0 or low or off if both two input is 0 or low or off. We are going to have high or on if any or both of the input is 1 or high. We are going to have high. So in that case, our C will be equal to A or B. So or C equal to A plus B. You can remember in our probability, when you have or, you use plus. So or is plus and is times. So if we are going to have an output, if any of these give us output, we are going to have an output. So we are not going to have output if both did not give us output. That's what we are asked to do there, and we have done that. So reduce the power supply to 0. Now we are asked to reduce power supply to 0. That means we now want to close this one. The next thing is to do is to check our to do the same thing for LED. We are going to construct LED and put the OR gate and see the reaction of it. Let's see now. This circuit is given to us. We need LED, we need transistor, so we need 2 diodes as usual. We connect the cathode of the diode, connect it with a resistor and ground it. So then the anode side connect to the switch, and so this is the circuit. You can see that we have the cathode side of the switch connected together, connect resistor to it and take it to the base of transistor. Then we need the LED. This is the LED connected. Then with the 2 switches, switch 1, switch 2. Then we have already, this is the power supply. This is the positive power supply, negative power supply. Inject 5 volt. Inject 5 volts to it. This is 5 volt into the circuit. So we now want to see what will be the reaction of our LED by the time we have. So we have been given table here 27 to 4 to fill. So using table 27 to 4, complete the truth table of the logic function for the diode digital logic OR gate. Confirm your result using the test circuit if necessary. Let's see now. So by the time we have 0 and 0, so we have already powered our circuit 5 volt, but we don't have 0, switch 1, 0, switch 2, 0. So what we have is 0. No light. no light. So no light. Let's now have, if switch 1 0, switch 2 is 1, switch 1 0, let's put this one to be 1. Let's see what will happen. So what do we have in our LED? So we have 1, our LED is on. So when we take it back to 0, it's off. Then let's take this one to be 1. So what do we have? We have our LED to be light up again. So by the time we now on the 2, on and on. So when you have switch 1 and switch 2 to be at position 1, what we have is 1. So this is what we are asked to do at table 27 to 4. So this verify the what? The OR gate. So reduce the power supply to 0. So let's reduce it back to 0. So we have 0, everything. We have it, so our lamp is off. So let's see what we are asked to do. Reduce power, okay. So adjust power supply to 5 volts. We've done that. Repeat the switching. We have done that. Which combination of the switching setting? Which combination of the switching setting? Let's look at our question. Now you will verify your logic equation using LED. We have done that. Connect the circuit as shown in figure. That's what we have connected circuit for. You adjust the power supply to 5 volts. We've done it. Repeat the switching setting of 27. What we did for the AND gate, we have to do it for the OR gate again, which we have done. The LED will light when the input gate conditions satisfy the logic equation. So which combination of the switching setting cause the LED to light? You can see that our LED light when we have in either of the switch, either or both of the switch on. We have our LED to be on. So we have 1 when either or both of the, that's what they asked us at question 4D. Which combination of the switch setting cause the LED to light? So combination S, when we have switch 1 to be equal to 1 and switch 2 is 1. And or when switch, okay, let's say switch 1 is 0, switch 2 is 1, or switch 1 is 1 and switch 2 is 0. We have on. We have on here. We have on in this one. But when we have switch 1 to be 1 and switch 2 to be 1, so we have on. We have on if switch 1 or switch 2 or the both switch is at on position. We are going to have on. Our light, our LED is what? Is light. So that's what they asked us to do. Does this verify the OR gate logic equation? Yes, it verify it. Because it says OR. OR means either of the switch. If it is on, we are going to have an output, and we have it. And so we have already filled our table. Use the table. So confirm result. We have confirmed our result through the table. Use power supply to 0. So we have off our power supply. Then from then, when you are now done, so our questions is there. So I believe all these questions are simple questions. If we go through the practical that we just performed, now all those questions we can be able to answer it with ease. There's nothing hard in those questions. Thank you.